All right, everyone, let's get the show started. Welcome to our DevOps office hours. It's August 31st, 2022. My name's Eric Osterman, and I'll be leading the conversation. I'm the founder and CEO of Cloud Posse, and we're a DevOps accelerator, which means that we help companies own their infrastructure in record time by building it with your team, all the while showing them the ropes. So if that sounds interesting, head over to cloudposse.com/quiz to book an interview with me directly, and we'll understand your situation and propose a solution on how we would go address that. For those of you new to the call, the format is very informal. My goal is to get your questions answered, so feel free to unmute yourself at any time if you'd like to jump in and participate. If you're tuning in from our YouTube channel or podcast, you can register for these live sessions by heading over to cloudposse.com/officehours. Again, that's cloudposse.com/officehours. We host these calls every week. Our call today is recorded. We'll automatically post a recording of our session to our YouTube channel. So if you enjoy the content and want to support what we're working on over here, please hit those like and subscribe buttons. So with that said, I'm already into announcements, one step ahead of the game. So I don't have many announcements today as I'm running a little bit behind. The top 3 announcements that came by my inbox today. One is if you are regular on Stack Overflow, you can now start to ask questions on Stack Overflow, tag Cloud Posse, and we'll be notified about that and can answer your questions there as well. Also, if you see any questions on Stack Overflow, feel free to, that are specifically related to Cloud Posse's Terraform modules and ecosystem, feel free to tag Cloud Posse on those as well. So here you can see we have 18 questions so far tagged. Any questions on that before I move on? All right. Then next one was a small announcement, an enhancement to CloudFront and how you can control access to S3 buckets using now origin access control policies that can restrict it to a specific distribution. Previously, I believe you could only do it using origin access identity, which was a little bit more limited, and you couldn't restrict it down to the distribution. So consideration there. Any questions on that before we move on? And the last announcement, it's not really a new announcement for regulars on the show. We've been following the releases of Terraform 1.3 alphas. Beta 1 just dropped. That means that 1.3 is imminent. I would expect it to come out in the next couple of weeks in that case. The main thing here is the optional attributes for objects, which we've been wanting for a long time, which concludes the experiment that was running previously. So if you were previously using the experiment, you're going to have to turn that one off and switch to the new convention of using the optional. I don't know, what do you call that? Looks like a function, but not a function, to specify if it's optional or not. Constraint. All right. Any questions on that? Other highlights of 1.3 that are worth pointing out? Oh, that's nice. Terraform format can now be used to specify a specific path without changing directory.
Yeah, Microsoft is phasing out ADAL, so they are removing that one.
They are phasing out what?
ADAL, like Azure Directory.
Oh, Azure. Okay, for authentication. Okay, that was not something I was aware of. So
yeah, they are using other graph version. Yeah, Microsoft announced it like maybe 1 year ago that it will phase out soon. Okay. So Azure is following that practice.
Good call. All right. So that's all that I had a chance to collate for today's office hours in terms of announcements. Anybody else have something that's worthy of mentioning? Vlad, you always have something good.
The UAE Breton launched. I haven't tried to use it, but it launched.
Oh, it's officially launched. Okay, cool.
And that's about it. Like there was the Fargate incident last week, just after office hours.
I saw your 40 tweet thread on that.
Yeah,
Or was it?
people really blew that out of proportion. It was, in my view, a boring incident, but again, I have quite a lot of experience, and yeah, that's about it.
So
No other announcement comes to mind.
what's the TLDR on the ECS incident?
It wasn't ECS, it was Fargate. So it was both. Let me.
Oh, so affected both EKS and ECS Fargate.
Yeah, so the servers behind serverless got cranky, and thus there were some issues. I don't remember the time. Like basically, uh, you couldn't launch new Fargate containers. The requests were failing, but they were actually succeeding after a little while, and that happened for like 8 hours or something.
Mm,
AWS reports 50 to 70% of requests actually succeeding, and that's in line with what I experienced. Like, yeah, stuff was
mm,
failing, but it was ultimately going through. Running containers were super fine. After about 8 hours, they didn't manage to fix it, so they stopped all new launches, which, yeah, that's a bit dramatic.
wow.
But
Wow.
obviously, it was a big problem. They couldn't fix it otherwise, so they stopped all new launches. Again, running containers were totally fine,
Mhm.
and then they fixed it and slowly brought it back up. It I go into this in the Twitter thread, but I don't see it as that big of an outage because it was very obvious from the very first second that, oh, only new containers are affected. So
Mm,
we're just gonna scale to the maximum and stop scaling down.
mm,
And you had like 8 hours available to do this,
mm.
which made this a non-event. But
Yeah,
Were
yeah,
they?
first,
it's a it's a non-event unless you run a business that relies on dynamically being able to scale your workloads up and down throughout the day as you're like processing ETL pipelines and that kind of thing. It doesn't seem like that would be great.
yeah,
Which I
for
guess
all
to
my
be
customers, we just blocked scaling, scale the high, and it was a non-event is mean of me. No, like it was still an incident, but it wasn't that dramatic. It was nice, not nice. Fargate is soon turning 5. Like at reInvent, it's gonna be 5 years old. So, and as far as I remember, this is like the first big Fargate incident. So,
Mm.
yay!
Have they come out with the root cause or?
I haven't seen any public documents on that.
Any other announcements from anyone else? AWS, Terraform, GitHub Actions related?
I saw a couple of small things. I saw that Memcached, they announced that that's now HIPAA eligible. That wasn't HIPAA eligible for a while. I have no idea, or forever, obviously, but I don't know what took them so long with that one. And then the second one I noticed is that they now have an SNS topic you can subscribe to within Security Hub that will give you all the Security Hub announcements and new features that they launch.
Hmm.
So you can kind of be programmatically notified of anything that they're changing within Security Hub, which I thought was pretty good, given that they do some things pretty rapidly there sometimes, and you're always like, oh, I didn't know that existed, but now they'll shoot that off to an SNS topic for you, and then you can obviously do whatever you want there. Send it to Slack, send it to different places, send it to your email, text yourself.
I wonder if they'll expand that to other product offerings and kind of have a standard way of disseminating that those updates.
Yeah, that would be interesting.
All right. Well, let's move into Q&A then. I think we have two questions teed up. One is by Jonas Steinberg. Jonas, I don't know if you were able to make the call today, but I did see your question there. And the question is, if you are in a kind of long-lived AWS organization and resources are managed within structure's code, but they're sprawled all across the organization in different repositories, how do you retroactively go about introducing tagging conventions, and what would the process for that look like? So I think it's a fair question. It's one that we at Cloud Posse basically never deal with because everything we do is based on using Terraform null label. So all of our resources are consistently tagged by convention automatically. But that's not a retroactive solution. That's not that's saying go and refactor and update all your modules to use Terraform null label, and that's not always a reasonable answer. So some of the suggestions that were brought up, one specifically was that there's a tool created specifically for this, which was TerraTag, which will run through every resource it finds and modify the HCL to add tags. I guess it's not worse than what you had without it. I just can't stand manually having all these tag attributes all over the place with hard-coded values. It doesn't seem like the long-term best solution, but hey, it checks the box and it gets you there. Other folks recommended using default tags within the Terraform providers. That's not a bad idea, I thought. Is there a way to create a SCP or a policy that denies new resources from getting created without the appropriate tags? Yep. So that would probably be what I would probably take a three-phased approach. Probably phase one, phase one is communication. Start getting people in the company to trying to tag these things. Phase two is a brute force. We're tagging everything with TerraTag. Phase three is implementing policy enforcement that anything new can't progress without having the appropriate tags.
Hey, can I throw something in there, Eric?
Yeah, go for it.
Give some thought to what tags you need. Depending on the platform that you're using to surface this stuff, and depending on your architecture, you really want to get that taxonomy nailed down to the extent you can, in a way that's flexible and will grow in the future before you start putting tags on stuff.
Tag sprawl, right? And the consistency. Also, it takes some time to figure out what that convention should be. So maybe try it first and let it burn in for a little while before making it canon law.
Yeah, one of the other things I would add to that, especially in an environment where the IAC is sprawled everywhere, is a tag that indicates like what module, et cetera, created the resources that are out there. That way, if you ever need to modify them, you can track down like how it got there in the first place pretty easily, especially like when it's in a decentralized model.
Yeah, that's one thing that's been really on my mind for a while. I've wanted to implement an introspection module for Terraform. I forget where the conversation is, but the idea is that you can actually, we'd probably be adding it to null label at some point, but where you can then automatically pass through metadata of where that code was provisioned from. So, inspecting the git config will give you a lot of that information from the clone modules.
Eric, I can tell you why that doesn't work. I've been down that path.
Well, to what extent?
Well, I mean, yeah, maybe it does in your case, but there is a gotcha in there, especially if you're using a monorepo, which maybe you're not.
But so one of the things I don't see working is trying to use commit SHAs, for example. That gets complicated pretty quickly because things change all the time.
So,
but tagging the repository and the module, I don't see that as being controversial or difficult.
Well, so you're talking about when you do like a Git or a GitHub reference to the module source, and it clones it into your config. Is that?
Okay, so yeah, in that case, okay. So if you're using a module reference, you're saying that you don't then get the same information. However, there's a better file. I forget what the metadata file is, but Terraform itself, when you do a Terraform init, has a JSON file that you can inspect in Terraform natively, and that's as far as I got when I was looking down. I can see what I.
Yeah, we tried to implement reflection like that. And we were going about, we thought we were really clever, like using the Git provider and looking at that. But it turns out Terraform does some weird stuff if you have multiple modules in the same repo.
Mm.
Hey, I ran into an issue, or not ran into, but I got to the point where I decided that I needed to tag our company services with one, with a tag, so that I could distinguish them from like all the, like the data dogs and all the security stuff and the Kubernetes based stuff. That can be very nice in your graphs if you want to break those things out, and logs too. We do that for logs. Just haven't done in a filter, in an incoming filter, but that's something to think about. We just slap a brace tag on all of our stuff, and then we can just turn off all the infrastructure stuff and give devs an app only view.
Yeah, sorry, I was not in focus mentally there, Eric. Here was the introspection example that we did here. So just using a JSON decode on this file, you can then extract a bunch of information, including the module and version. And since that file is created by Terraform init, it exists before the lifecycle of your plan and apply, and therefore the strategy works.
I use that to set an SSM parameter in each environment for the last version.
Oh, you do?
Yeah.
Oh, that's cool. That's cool.
Just wrote a little info module for that.
Eric, can you repeat what you're trying to do for your application?
Yeah, it's really simple. I just added a tag to identify our stuff versus like the infrastructure stuff, so I can give the devs an app only view.
Mm-hmm.
We do that in logs in Datadog and incoming filters. Though, I'm trying to move that to tag based. Yeah,
we use tags. We use a team and service are the two tags we use for that. And then service could technically comprise multiple apps, I believe. All right, anyone else have any more thoughts on tagging?
Oh my God, is there any more satisfying activity?
Once it's all tagged, it's pretty satisfying. You can finally see.
Well, yeah, that's what I mean. Getting it tagged is like, you can face your financial people with confidence.
Yeah, exactly. Finally, that question you dreaded, you can actually answer. And the tagging isn't limited at just AWS resources. It extends all the way into the things inside of your Kubernetes clusters, for example, or ECS clusters. So.
And within Datadog, if you're using Datadog.
Right, yeah.
Which can come back to bite you if you're trying to debug it and you don't realize until maybe an hour is generous later that it's set in Datadog, not in any of your code that does absolutely everything else. Something to be aware of.
Sounds like a hard lesson learned.
Actually, you'll like this, because what I did was I set the host filter in the integration. I've been thinking about your new integration, checking out your Datadog integration module. But I set the host filter to Datadog true, and then I set the host tags to Datadog true. And I'm having conversations about why the hell are all of our hosts showing up in Datadog? So yeah, love that.
All right, next question, similar to what was brought up, I think, in a previous week's office hours, was just like, how do you get started with Atmos and Cloud Posse components? Omar Sen, I know you're engaging in a new project and you're looking to get started on that. If you've been following Cloud Posse for some time, you might be confused because sometime around 2 years ago, we switched from one pattern to another pattern. Previously, we were using like one Docker image per environment, and we were just using pure Terraform CLI commands and environment variables. We learned that that pattern did not work very well in the long run and scale very well because, well, you get this sprawl of environment variables just everywhere. And the problem with environment variables is they're hard to enforce, that, they have been set or haven't been set, and where were they set, and validating them and so forth. So we rethought our entire strategy a couple years ago, and we moved to this new strategy of stack configurations. So, oops. So if you go to docs.cloudposse.com, we do have some, if you spell it right.
You're missing, yeah, the S.
Yeah, so we do have some tutorials here, but I'll be honest that these are based, these are a year out of date and haven't yet been fully haven't been updated to work. One of the examples we use relies on a weather API, and that weather API has gone away. So one of the hard parts about doing examples is always doing something that's not too contrived, but also not so advanced that you need to be an AWS expert to get up and running. So we have two tutorials here. One getting started with Atmos, which is this configuration management tool we built that's designed to manage complex configurations for Terraform, but also Helm file and eventually other tools as well. Atmos combines concepts of like a task runner with concepts of other wrapper tools like Terraground, Terramate, TerraSpace that exist out there. So Atmos is our way of keeping your configurations incredibly dry. I'll show you an example of what that looks like. And then geodesic is enhancement. So geodesic is designed to not be opinionated for like what tools you run or whatnot. The idea is you need a shell, you need a toolbox image that your developers use for a consistent developer experience when working with infrastructure code or your tool chain. Geodesic is one way of doing that. You don't have to use our image, but it's a great way to start. So those two projects are Cloud Posse Geodesic and github.com Cloud Posse Atmos. So I want to try and paint a picture, at least for those who are looking at this, because that's the best I can do right now. Most of our documentation is still in our own private Confluence and not public. So Atmos is this tool. It is a Terraform wrapper, technically. Atmos was designed to take a complex YAML configuration and through levels of inheritance, create one configuration, write a TF-var file, and then call Terraform. This means that when you use Atmos, you're truly using vanilla Terraform and a tool to help you generate your variable files. And that's the extent of it. Here's what that enables us to do at Cloud Posse. So, and if you're just looking, one of the common questions is, how do we organize our infrastructure? And what's the Cloud Posse way? So we have two concepts. We have this concept of components, which are your Terraform root modules. And we have this concept of stacks. Stacks are your configuration. Most companies that do Terraform combine configuration with Terraform code. I mean, technically, HCL and Terraform code was designed to be configuration. It's the configuration of your infrastructure. The thing is, it's evolved, and it's evolved to be parameterized and have variations and call modules and so forth. So we decided to treat Terraform code as Terraform as business logic and treat configuration separate. All right, so what does that look like then? Well, under the hood, your company, you're going to create a repository. We recommend a monorepo. That monorepo should have a folder called components. And underneath components, create a folder for every tool that you're using, because you might have multiple top-level tools, like Packer being one, or Helm file being another. So our convention is, under the components, create one folder for Terraform, one for Helm file, one for Packer. All right, going into Terraform here, we want to now create a root module for what we want to deploy. This is the building blocks of your infrastructure. What we always see companies do, but isn't our recommendation, is they'll create a heavy root module that combines things like, it'll have the VPC, it'll have your EKS cluster, it'll have your ECR repo, it'll have maybe your RDS database all in one module. That is one way you can do things, but now that's one complex pattern with a lot of Terraform code with a big blast radius. So we don't do it that way. What we do is we create a lot smaller root modules, and our root modules, you can see right in front of you here, demonstrate that. So we'll create a root module for ECR, a root module for EKS, a root module for WAF, and so forth. And guess what? We give away all of our commercial root modules also as open source. Those are free. Those are under this repo called Terraform AWS Components. We keep these updated these days. We didn't used to, but now we are updating it, and we're using this as our origin for all of our engagements. So this is a nice process to keep them up to date. Now, these root modules have then examples on their usage. And if I jump into cluster here, you'll see a sample YAML configuration for how it's invoked. So how do we manage all those YAML configurations, and how do we keep environments dry? Because one thing you'll notice when I look over here is this isn't mostly a flat directory structure. It doesn't convey your architecture, because architecture is configuration. So when we jump over here to Infra Live, we look at your stacks, and your stacks are broken down into 3 different conventions. One convention is what we call a catalog, which is like a library of reusable configurations. Mixins, which are also a library of reusable configurations, but are designed to be imported into other like catalogs or other stacks. I'll show you an example. And then your actual stacks. Now, stacks is an incredibly overloaded word. That means a lot of different things to a lot of different people. For us, a stack is the collection of all the root modules that have been invoked for a given stage. For us, a stage is what many people call an environment. And that stage, we by convention restrict to an account. So we'll never have 2 stages in one account by convention. So you'll have one Amazon account, for example, for staging, one Amazon account for dev, one Amazon account for production, and so forth. So the other thing to think about is, how do you organize your infrastructure when you have this repository? Well, Amazon's made this really easy. Amazon has this concept of an organization, which is like your top level root payer account. And then that organization has organizational units, and those organizational units have accounts, and those accounts have regions, and those regions have resources. So that's how we organize it by convention. Again, it's not an enforcement. It's just, this is just a recommendation for how you might want to configure or organize your configurations. So here I show you what that looks like. Here we have an organization. It's called CP Live. Yours would be called something different. Here we have 2 organizational units, one called Core and one called Plat. Plat represents the platform organizational unit. You might use a different convention, no sweat. This is what we've kind of settled on. Then in there, you'll have a folder representing each of your account stages. One of those stages might be staging. And then you have everything broken down by region, because that's the next level of demarcation within Amazon. And then regions have resources. So here you can see by convention, everything we do is multi-region. We disambiguate between Amazon's global region and regional resources. So the things like IAM and Route 53 that are global, that don't make sense to couple with a region, and then things that are tied to some resources in a region. So here's what that looks like in the end. You know, we have this YAML configuration, and you can see that because it's YAML, it's very easy to just come up with your own DSL, your own convention. That's what we did. We have this concept of imports, and we import our configurations, one catalog entry after the next. All of these are just layering and importing in. And then we override our settings down here below. So Omar, in planning on how you're going to start rolling these things out, the first thing I would do is start by setting up your infrastructure repository scaffolding and representing it in something like this. And then the next thing you're going to want to do is decide on what are all the pieces that comprise your infrastructure. So you're going to want to have something to manage accounts. You're going to want to have something to manage your VPCs. You want to have something to manage maybe your ECS or EKS clusters. So that's where you go into your catalog. And your catalog is where you start building up this library of all your reusable configurations. So a baseline configuration for ECR, for example, and a baseline configuration for your VPC, for example. Now, some of these baseline configurations are what you can pull from our AWS components. And when you look at the README, there'll be an example usage here. I can't promise it's going to be fully up to date and have every option exposed, but you get the gist of it. And once you have your catalog in place, and then you can start, putting those stacks together. And then you use Atmos. Atmos is the tool that will read that YAML configuration and generate your TFR files and call Terraform. And that's the pattern.
Have you heard TerraSpace?
Yeah, definitely heard TerraSpace, TerraMate, TerraGrunt. There's tons of them now. Yeah.
Oh, okay.
Yeah, TerraSpace is another nice solution out there. I think TerraSpace probably appeals especially to any shops that do a lot of Rails development today, because TerraSpace is a framework written in Rails. TerraSpace has a very nice onboarding experience to create and generate a new project. Now, you're going to find a lot of these tools out there, and those tools can probably help you achieve similar things that we do. The biggest gap between those tools and what we have is that we have this holistic solution. So what we are doing is, hey, we're giving you a tool to manage this complex configuration. It's what we use ourselves every single day in dog food. But then we also provide this insanely large library of all of our components here that are exactly what we use in our customer engagements themselves, and that themselves leverage all of our other modules. So you could probably come up with something similar in TerraSpace, leveraging some of our modules and so forth. But yeah, it isn't the solution that we are investing in.
Hello.
Hi.
Hi.
So yeah, any more questions? Yeah.
First of all, I would like to excuse myself for last time when there was a huge audio issue when you guys said, "Whoa, what is this?" Oh my god.
No worries.
Now it seems fine. Can you? Now it seems fine.
No issues today.
Okay. I wanted to say. So you said like monorepo. So you would say you would recommend like all the infrastructure for some organization, some organization to have in one repository, like
not really, actually.
okay.
So I recently answered a question in the general channel on sweetops addressing this fact. Here's the thing. Okay, so first, standard disclaimers, what works for one organization doesn't work for another organization. Your mileage may vary, but the gist of it is this: depending on the size of your organization, as a business, as a company, you're going to need different things at different times. And there can be things that we say are a best practice for how you organize your infrastructure repository that I would say is maybe an anti-pattern if you're going to be, a Disney scale enterprise adopting these strategies. So what our opinion is on this is that you need a monorepo for your foundation, because your foundation is your root, and you always need a root to some degree. You generally don't want to have 200 roots spread all over the place because it's difficult to manage. So our opinion is you need a root with your foundational infrastructure. That is maybe how you manage your accounts, how you manage your organizations, how you manage your service control policies and your organizational cloud trails, how you manage Security Hub and Guard Duty and things like that. Then with your foundation in place, you can start thinking about how do we want to enable infrastructure for teams and services. And those teams and services, it might make more sense to allow them to manage their own Terraform code, their own infrastructure as code. And then it becomes a question of, well, should they have their own monorepo? Or should each service have its own subfolder, for example, with infrastructure code? And we've implemented both for customers. Most recently, we've done this pattern where a team will have, like a data analytics team, will have their own infrastructure repository with only the infrastructure code that is relevant to that team. For example, that data analytics team might care about Airflow, Kinesis, Glue, and Redshift, and EMR. Well, you would put all of that business logic, all of that configuration in an analytics monorepo. What I think is a dangerous trap is saying that you have to go one way or another. And I think it's also a dangerous trap saying, well, if you have 500 different GitHub repositories and you're going to have Terraform code sprawled across all 500 of those repos, that also becomes a new kind of management challenge. So did that answer your question?
Yes, yes, definitely.
Okay. Okay. So the other thing I'd like to highlight with all of this, and it's something I frequently tell people when we're on the phone with them and selling Cloud Posse services is, you know, it's all fine and dandy when you have your infrastructure defined as code. You feel great when your repository has a wealth of infrastructure code in there, but you have no idea what your tech debt is, your liabilities, and your deployability at any given time. You don't know what the state of that. And that's why you need another layer then on top of everything that you manage here. So that's where Cloud Posse has gravitated towards a paid service called Spacelift. And Spacelift gives us that visibility into the state of our infrastructure. So everything that goes into main, we can see it at a glance in Spacelift. So with Spacelift, I'm going to filter this to folders and states. So here you can see the state of our infrastructure broken down into those organizational units, core and plat that you saw in the repo, by region, global resources and regional resources, and by account. So if we drill into staging, we can see the resources deployed in staging. And by state, we can see that there's a total of 27 resources deployed to this environment, of which 1 is pending changes, 23 are healthy, and 3 changes were actually skipped. This is like if you're familiar with accounting software, having double entry accounting, where you see every transaction come into your checking account, you want to have it mapped to something else within the business, one of your other expense accounts and so forth. So that's what we get with Spacelift. I think you could try and do something with Atlantis and other software, but I don't think it'll be as easy. All right. Any more questions on that? Let's see the Zoom chat.
How do you handle like your backend state file management for all this?
That's a good question. So Terraform state backends have historically been one of the more painful areas of getting started with Terraform. Tools like TerraGrunt automatically generate that state backend for you. I always found that kind of awkward though, because hey, we're managing our infrastructure as code, yet this other tool is not following that. It's just creating that bucket for you. So we've taken this other approach where we have a Terraform module that provisions the Terraform state backend, and then we have a little bit of rough edge there where we have to create that backend without a state backend and then import the state into the state backend. So it's a little bit recursive there. But here's the deal with that. It's a cold start problem. It's a problem you have one time with one state bucket. Now we support ACE architecture, which can have multiple Terraform state backends. And guess what? The state of the state backend buckets are all in that one root state. So it's only thing you have to do one time in the generation of your organization on AWS, and then you can start creating Terraform state backends all day long, however many you want in any account in any flavor. What gets tricky with your Terraform state backend architecture is 2 things. How are you managing your IAM roles to restrict access to those buckets to who needs it? And then how are you deciding on splitting those buckets across your accounts? So are you going to have a convention where, hey, we're just going to have 1 Terraform state backend per account, or we're going to have 1 per account per service, or we're going to have 1 for production and 1 for non-production? And then based on whatever strategy you pick, if you depend on Terraform remote state, have fun, because you're going to have to do all these calculations, the hard way by knowing which state backend to look at that. Now, if you're using our module ecosystem, we've solved that we have, because you're using YAML stack configurations, every Terraform module knows about every other Terraform. Every Terraform root module knows about every other Terraform root module and where it's deployed and how it's configured and where its state backend is. So when you use the Cloud Posse ecosystem of root modules, state management becomes very easy.
Thanks.
Yep, sure thing. Did I answer the question? How we manage state backends, or?
Yeah, you did. I mean, I guess to elaborate a little more on the question is like, in your bucket, what does your bucket like architecture look like for your staging? That's kind of what.
Yeah, that's a great question. Hold on. Here is what that looks like. Oh wait, this is, yeah, so I think we had a different document I was thinking of, but this kind of shows it here too. So what we'll have is one bucket with a folder per root module. And then each root module then have a environment, or AKA AWS Terraform workspace, and then the Terraform state backend within that workspace. Now there's all this FUD, all this fear, uncertainty, and doubt about, should I use Terraform workspaces, and they're evil, and this circular references, and how it's just the worst thing ever. And yet that's all we use for years, and it's been no problem whatsoever, because it all comes down to your tooling. And you can very easily shoot yourself in the foot with Terraform with things worse than running Terraform workspace the wrong way. So in the end, anybody doing Terraform at scale, anybody doing anything meaningful at a large scale with Terraform, you have some tooling. You might have some bash scripts, you might have some make files, you might be using TerraGrunt, you might be using all of the above, you might be using Atmos, which is our tool that we use for this. And that tooling is what's responsible for making sure you have the right workspaces selected. So that was me on my soapbox, because it's come up recently.
Yeah, that's a good thing, because I use Terraform Cloud and everything's workspace based in Terraform Cloud. You have to have a workspace, yeah.
It is. Actually, it is and it isn't. So, so to be clear, when Terraform Cloud came out and they're using workspaces, I thought, yay, it's vindication for using workspaces. Except for Terraform Cloud workspaces are not Terraform open source CLI workspaces.
No, they're very different. Yeah, they're very much different.
But anyways, I'll take it as a win either way, because we use workspaces. So. All righty. Any other questions on how we manage Terraform state backend and what it looks like in the buckets? All right. Oh, one other key thing here, and I think it's always overlooked, unless you've thought about it, is your Terraform state backends. And if you are taking a multi-region DR approach, think about what that means in terms of what region is your primary region for your Terraform state. And I think it wouldn't be a bad idea if you created a Terraform state backend at a minimum per region that you operate in, so that it's very clear where your state is. Because the worst that would happen is all your state is in US East 1, and your whole purpose for being in US East 2 or US West 1 was in the event that US East 1 went down, and then US East 1 went down for some period of time, and S3 is unavailable, and you can't manage your Terraform resources because all the state's locked up in that one region that's down. All right, let's see. Any more questions here in the Zoom chat? Mike Martin posts, about 23 hours ago, Eric posted on his LinkedIn, couple this with curl provider to automate one-off APIs that lack Terraform support. Well, okay, in the interest of full disclosure, we are not using this pattern I'm just saying, I'm painting a picture on how these two things become useful. So the first thing was a generic Terraform provider for curl, or a Terraform provider to do generic requests, HTTP requests with curl. So now we know we can construct any HTTP request more or less and do that in Terraform. Thing is, there's most things that you want to talk to need a API token. Many things use OIDC. So using the OIDC provider, you can now generate the request token that you need to make that request with the Terraform provider for curl to automate that one-off API. And that's why I'm calling it one-off. I'm not saying, hey, this is the best things in sliced bread. We don't need to use the Terraform AWS provider anymore or something like that. There's this one thing you might need to do with Terraform to get around some edge case you ran into, and rather than implement yet another weekend project Terraform provider, because that's what half the Terraform providers are, you can maybe combine two other Terraform providers to make that same request. I think an example of this might be a request to, well, okay, so I don't think you can do GitHub, I don't think you can do OIDC requests workflow with AWS APIs. But like a one-off situation, making a one-off request with the curl provider would be you need to call the AWS API to stop a service. So Terraform isn't responsible for stopping and starting services. All it cares about is create, update, read, and destroy operations, not stop and start operations. So typically people would just say, hey, I'm just going to use the shell provider and call the AWS CLI directly. Well, maybe you could also now use a curl provider to make a lower level request to that same service using native Terraform without depending on CLI commands. We are not using this pattern anywhere yet. I just want to make sure people are aware that you could, this is something, if you ran into these problems, look into it.
Yeah, I like the last
and
example you provided, where Terraform isn't responsible for starting or stopping, but you could use it to do such a thing.
Yeah.
Yeah, I was just going to say, Eric, that you can in fact call the AWS the AWS APIs with a GitHub OIDC token. If you can get that token, you can exchange it for temporary AWS credentials, and then you can do whatever you want with that.
Right, because that's how the GitHub OIDC stuff works. Duh.
Yeah.
Okay, thanks for connecting the dots for me.
Yeah.
Are you guys integrated between Spacelift and GitHub OIDC? Where's your user? Like, how do you use?
That's
Google?
an interesting one. So right now, we have some GitHub actions. We have used GitHub actions to trigger deployments in Spacelift. That works well, but the problem is we need to have this token in GitHub actions that can deploy a stack in Spacelift, and that's a hard-coded token that would need to be manually rotated. I haven't looked into it. Is there some way that you can have Spacelift trust the GitHub OIDC and then do short-lived credentials to trigger jobs in Spacelift? I haven't seen that, but I'd be curious to ask them.
I thought it was some new functionality that just popped up. I haven't even been able to look at it. I don't know. Matt's me in the face.
Yeah, I'm just trying to figure out how. So the way that. So just to talk through the flow, the way that GitHub OIDC works is that the GitHub service trusts its own workflows that are running and it issues them an OIDC token based on the fact that it controls the spin up of those things. So it knows like when a new job starts, and it issues it a token, and then it's that token that you can call the AWS STS endpoint with to be able to exchange that for temporary AWS credentials. I don't know how in this case GitHub would trust Spacelift in the first place to be able to issue Spacelift the OIDC token, because usually in order to do that for a service, there's a password flow. Like you would have to somehow you'd usually have to log in. It's not a machine-based flow like OAuth is. It's actually has a username password, and they're just hijacking it because they control both the client and the server in the GitHub actions workflow.
That makes sense to me. So that it just wouldn't be possible in that case, because
Yeah,
they can,
unless
like
they
you
have
say,
some other thing, that
Yeah.
they're doing.
Okay. All right, let me check the office hours channel here. See if there was anything posted there. Oh, there's the post on the Fargate outage in the office hours channel. And scrolling up here, I see Mazin asking question. I'm trying to import a Google Project IAM policy that looks like this. Based on the documentation, it should be imported like this. However, when I use this one followed by a Terraform plan, let me share my screen. It shows the role being deleted instead. I'm not sure if it's related to importing data sources or if there's a better way to import.
Is it also being created? There are changes that require replacement.
Sorry, I didn't hear you, Eric.
Oh, what was that?
I asked if it was also being created. There are changes that require destruction and creation.
Fun part that happened
Yeah.
is every time I run Terraform apply, a different thing happened, and I have no idea what does that even mean. But literally, if like for this GCP project, I have like 5 different roles, and suddenly one is being deleted. The second time, another one is created. The third time I run Terraform apply, it's being deleted again.
Do you have a backend set up? Do you have a remote backend configured?
No, it's a local setup, and no one else is touching the project, which is funny.
Are you using count by any chance in your resources? Like count equals 4 or something like that, and you're iterating over that?
No.
No.
Just
Okay.
the plain code that looks that is generated that looks similar to this one. It looks like it's a bug on GCP, like Google
The provider.
project IAM, the provider. But I have no idea if someone else have a better experience on terraforming IAM roles on Google.
Yeah, I don't have a lot in Google, but what I can tell you is in AWS, they had a problem for a while where the JSON the JSON wasn't that comes back when it does the read out of the API wasn't consistently coming back in the same order. So it actually thought that like it needed to delete and then recreate the same roles for a number of times. And they finally fixed that bug not too long ago. I wonder if Google doesn't have a similar issue.
Wow, this is almost exactly what is happening here. And because I imported, and then it tells me that hey, it's different from what you're applying. So maybe this is the same behavior, which is really funny.
If you want to verify that, you can probably turn on TF_log equals trace and actually look at the data, and you'll actually see the API calls that are being made to the Google APIs and the results that come back. And you can compare those if you run it several times, see if you get different ordering, and then see if that in fact corresponds to that. And then if it is, just open up a bug on the provider and tell them like, hey, here's what the problem is.
Perfect. I think that's the way that I would be doing. Thank you very much, Matt.
Yeah, no problem.
So one of the questions that was asked in office hours earlier this week, so I didn't see it, was just this person's considering using AWS Code Artifact. Love it or hate it. We're considering it for PIP. Would love to understand if there are any weird edge cases. Previously, they've used Nexus Artifactory and run into some problems there. So I guess it's probably fine for pip. My biggest complaint is it doesn't support some of the artifact types we've wanted to use. So that's why we don't use artifact or code artifact for like date. I think it doesn't support like Debian packages and RPM packages. I was just trying to verify that because my recollection could be wrong.
Yeah, mine was really dated, and I was actually doing the same thing.
Which has been my frustration also, like with GitHub packages. Like I would love to use GitHub packages, but we can't use it for the packages that we distribute. And they are very common packages in my mind, like RPM packages and Debian packages.
Yeah, npm, PyPy, Maven, and NuGet. That's it.
Yeah.
This all makes me want to ask you how you manage versions across everything, all the dependencies. You know, you have crap loads of stacks of different versions of Terraform and different versions of providers and modules. How do you manage that? You guys have a lot more than we do. Looking for
yeah, so the problem set reduces a little bit when you think about the number of tools that you really need to worry about pinning the versions on. And that's why what we did was about, I don't know, maybe it's 3 or 4 years. No, it's like, yeah, 3 years ago, maybe. We realized that more and more we were becoming a package, just like an OS distribution almost with geodesic. And one of the biggest problems with conventional operating systems is that they don't support concurrent installations of binaries or like different versions of software. Obviously there's somebody help me. What's the new cool kid on the block that everyone's talking about for the OS, where it literally sandboxes everything that you install, 3-letter acronym or something. Anyways, but for NPM and those packages, you can't do that. So what we did was we distribute our own versions of Terraform.
Did you mean Nix?
Nix OS, yeah, exactly. So
Yeah,
it's not a problem you have with Nix OS, but it is a problem you have with every other OS out there that I know of. So what we do is we come up, we do two things. We create a base package, which is always the latest of some series. And we don't do that for everything. We do it where it matters. Terraform, it matters, right? Major differences between Terraform versions and not backward compatible. And then we create a package for every other version. Now, in this case, for Terraform 1, Terraform has come out and promised backwards compatibility. So that's why we aren't being as surgical about pinning this way as we were previously. And we do the same thing with kubectl, providing an installable package that way. So when we do this, we can now use the established convention of alternatives, which is an OS, which is something I think Debian introduced, but it's supported by the major operating systems now. So depackage alternatives. So depackage alternatives allows you to have multiple alternatives for the same package, and then you can select which one of those you want to use. And that's what we're using. Now, I went this way because I like to think of myself as an old school Linux kind of guy. And I just want to use like the fundamentals that Linux provides. Then you have some other alternatives that are probably a lot friendlier to use, which are things like all your env managers, env environment managers that they have out there. Drawing a blank on what the most, ASDF being one of the most popular ones. Are you familiar with ASDF?
Yeah, there's a few things out there. That's like a Swiss Army knife.
Yeah, exactly. It's like a framework for doing this. And then it supports ways of switching between everything. So our problem is a little bit reduced. So we had this problem very early on as a consulting company working with, you know, multiple concurrent engagements and customers at different versions of Terraform and Kubernetes or not Kubernetes and so forth. And we didn't want to have that problem. So that is why that was the original impetus for creating geodesic. So geodesic is this Docker image, and it's a base image. So you inherit from this base image, and now you have an interactive shell for your environment. And you can create as many of those shells as you want. It's kind of like if you were using back in the day, HashiCorp's other tool for managing environments with virtual machines,
Vagrant.
Yeah.
Vagrant, yes, thank you. It's like a Vagrant approach, but Vagrant is pretty heavy-handed, spinning up VMs while using Docker images for projects that need pin tooling is a pretty lightweight solution. For most of our customers, that works out that you only need one geodesic container for the tool set. However, we do have one customer that took this to the next level where they have multiple AWS organizations. And then like for each AWS organization, they manage a separate toolbox image. So the toolbox image is our predominant recommendation for how you manage all those different versions.
Yeah, and I think just to take this all the way down the path in the Atmos stack configs that we have there, you have the ability in metadata to set the version of Terraform that you want to use for a particular stack. So, and Atmos will do the right thing and swap itself to those different versions of Terraform when it's planning or applying that particular stack. There you go.
Yeah, so exactly, this is what we're talking about, is that Spacelift has this concept of a version for a stack, and what they call a stack is what we call an instantiation of a component, and you can specify the version.
So I was actually talking about line 7 though, that even without Spacelift, if you're running this just with Atmos, you can have different versions of Terraform for different stacks. And then that way you also, I wouldn't say like I would encourage you to go do this, but it really helps in a migration scenario. Like when you're upgrading, you want to get like move from 0.13 to 1.1 or whatever. You don't have to do that all at once and update like your entire file and get it all working. You can do it like one stack at a time, pretty easily through that migration process. So it's very helpful that way.
Yeah, my config expose is pretty much the same thing. For all my multi stacks that are applying the same module across multiple stacks, they get the same config. Shit, I just totally forgot what I was saying.
It happens to the best of us. Yeah, Terraform versions, how we set them, how you do it in your config.
Oh yeah, sorry. So it's a YAML file for each multi-stack with the default, and you can just change it in the default and then override it in the specific. And then when that's done, you just change the default and roll it on through. There are also some tools that will inspect modules and go out and look for like latest versions of dependencies and stuff like that. I think there's probably a pre-commit or an easy one to write for that. At least I want to be able to track, all these things, and instead of, I'd like to be proactive on this instead of going to the EKS console and having them taking up real estate, telling me that I have plugins or add-ons that need upgrading. There's a lot of axes to this problem.
Yes, there's a lot of axes to this problem, which makes it so difficult. Yeah, there's, like you mentioned, and then the tools within your cluster and whatnot. So I don't think there's
I was just gonna say, Dependabot does a pretty good job across a whole bunch of different languages, including Terraform, of letting you know when you're out of date on your dependencies. That's really good.
We actually use that. I'll look into that. Thanks.
Yeah, and RenovateBot as alternatively. I don't. Does anyone know with Dependabot? With Dependabot, can you come up with custom expressions to update arbitrary files? You can.
Yeah,
Okay, 'cause
there's a
Renovate
way to
Bot
do it.
does that. All right, we went way over today. Thank you everyone for hanging out there, giving us 10 extra minutes of your day. I'm gonna wrap up office hours now. We'll continue next week where we left off. If you haven't yet subscribed to our YouTube channel, head over to youtube.com/cloudposse. Again, youtube.com/cloudposse and subscribe. I appreciate it a great deal. Connect with me on LinkedIn. Go to linkedin.com/in/Osterman. Again, that's linkedin.com/in/Osterman. And if you are interested in working with Cloud Posse, it's very easy. Go to cloudposse.com/quiz and book a meeting with me and see if we are a fit for your business and helping you take it to the next level with infrastructure as code and automation. So talk to you all later. Adios.
All right,
Thanks.
guys. Have a good one.
You too.
You too.